Okay. Good evening again. The meeting officially started. I start recording. I want to say a few words and we'll leave you with Professor Wu, who is the one he is running the second part of the course. And it appears that the volume is not okay. Let me see. I hear very well. Let me start with higher volume. Is now the volume okay?
Yeah, it sounds good.
No, I just received a message that it's not okay. Chris, can you hear better now? No, she's not. Well, I think she doesn't have audio. Chris, you don't have audio. You either have to go through the computer or call the phone for WebEx. Okay, okay. She's going to manage. She will join us shortly. So as I said, today presentation is going to be by Professor Wu. I just want to make few remarks for the up to here for the course. Well, as you know, we are already in week 9, so the course is running very, very fast. And I find out some surprising questions that people still don't know that we are doing work in Watson Analytics, which is different cloud environment for the group project, where the data is. This is pointing me to the direction that people are not reading the most important thing in the class, starting with the announcement from the first day. So also, I feel some of you are not clear what Bluemix is, because in the last assignment I read, Bluemix was named everything except cloud platform. This is just cloud platform. Bluemix cannot do analytics itself. Bluemix is a cloud platform as a service, which has a lot of services, including services for analytics, the ones we are using, but there are many other services we are not using for this class. So this is very important point to keep in mind. And secondly, keep in mind that this is production environment. I mean, this is working real production environment for which company pay for service. We are just getting this for free, but that doesn't mean this is free service. As a such, the performance and everything required by the customer should be up to the contract. So what we can expect from Bluemix? I can tell you from our previous semester experience, and this is the real experience actually you will have in any company you will be working in the next few years. Everyone is moving all the applications, all services is much cheaper to the cloud. So this is the usual environment you will find in your work, and this class provides you, in addition to teaching you the analytical skill and big data analytics, which is the topic of this course, the environment in which usually you will be finding to work in the next year. It could be Amazon, it could be Azure, it could be the IBM Bluemix, it could be any other cloud environment. This is the reality. So what we can expect? Usually they are scheduled maintenance, okay? They are outages from time to time, and we experienced already one single service outage, which was exactly, unfortunately, the one we were using for the assignment. But this always is the case. This always happens this way. There are just one service outage, and that was the one we were using for our assignment. So this is, again, take it with open mind, because this is the reality which you are going to find in your work environment. You have to turn tomorrow your project for work, and this service is like today is either downtime for some reason, unexpected, or maintenance, or update in version. We can expect any of these things, and this doesn't undermine the advantages to have to work in this environment. So I just trying to communicate to you so you get better idea what is this, what to expect, and what is the benefits for you working in this environment. With no more, I will give you the word to Professor Wu. Jungho, are you ready to share the screen and start talking?
Sure.
Okay,
yeah, let me share the screen.
Okay. You have the, yeah.
So, can you guys hear me?
Yes, it's perfect. We can see you.
Also, you can see the slide here, right?
Sure, yes.
Okay, thank you, Elena. So then, let me start reviewing the Big Data and Spark here, including the assignment 4.1 and 4.2. You know, this slide that I'm presenting today is actually in the website. If you go to content, if you click on content, you can find out this lecture note, this slide. So today I'm going to introduce big data. Most of you, you already get the concept of big data and what is Hadoop, what is Spark, but I just want to review just in case. Also, the Spark is the most popular platform these days for data analysis and data science, especially for massive data set. So I'm going to introduce Spark. And what is RDD? That is the resilient distributed data set. And that is the core of Spark. And also introduce some Spark APIs such as Spark SQL, Spark Streaming, and Spark Machine Learning Library. And then I also briefly introduce Bluemix and how the Spark can be run on Bluemix. And then I'm going to review the assignments 4.1 and 4.2 to make it clear. So, as you know, by the way, I've been exposed to big data Hadoop around 2007 when I consulted a company named cresearch.com. That is actually a competitor of Yelp.com. And we had the issues for storing massive data set, actually massive business data set, plus to generate XML data from the existing business data and the review from the users. But at the moment, from Northern California, actually from San Jose, we get the rumor that there is a really nice platform called the Hadoop that could, actually big data and Hadoop that could resolve this issue. So as you know, for past several years, we've been observing the large scale and massive data set that is like a terabyte or petabyte, more than terabyte or petabyte. It is because we have a web, and as a Google experience it, if you want to analyze the web, you need to actually look up all the webs that are actually kind of petabyte data. Also sensor data, and people normally call it like Internet of Things. Sensors generate another large scale data set. Also bioinformatics such as DNA, human genomics, that has too much data, and social computing, including your cell phone, like a Twitter, Facebook, that generate too much data. And at this moment, even though you are watching my talk, you actually generate a lot of data from your smartphone because you have your location information. Also, you are like chatting with your friends, right? Also, online game, there are too many, like millions of users who generate like events and to purchase some items to beat the opponents. So simply, we live in the era of massive large-scale data, or simply we can say big data, right? The problem here is we cannot handle this massive data set with the legacy approach because simply the data is too big. Also, data that are generated are actually non-structured or semi-structured data. You know, the traditional approach use table to keep data as a structured data set, right? Because table has column and row. But this kind of data that are generated these days are actually non or semi-structured data set. And also, using the traditional approach, we actually can handle this non-structured, semi-structured data set, even though that is too big. Only problem is it is too expensive. Using Oracle database, you can handle them, you can store them, but you need to spend like millions of dollars. So we actually need a new system that shouldn't be expensive. And fortunately, actually, Hadoop came out. So again, there are two cores in big data that we have to consider. The first one is how we can store this massive data set. Second issue is how we can process this large-scale data set. Actually, Google is the first company who have experienced this issue. So Google actually built their own system to store large-scale data set and name it like a GFS, that is Google File System, or Google Distributed File System. And they use non-expensive commodity servers. That is about like each server could be like $5,000 or $10,000. Comparing to like a storage and others, it is relatively cheaper. And these are servers that we always use. And if you cluster those servers, maybe in Google, maybe you have like 10,000 servers that are clustered together for collecting and indexing data from the website. So anyhow, Google has their own file system to store this massive data set they collect from the web for indexing. Also, the Google has their own system to process this large-scale data set by using MapReduce approach. That is kind of famous the approach in the artificial intelligence area to handle like a data, especially for massive data. And their researchers, their computer scientists and engineers adopt MapReduce approach to process this large-scale data set. So and they are distributed parallel computing with like tens of thousands of actually about 15,000 multiple non-expensive commodity servers. So Google actually find out the way to own supercomputers, because supercomputer is nothing else but the parallel computers. But supercomputer that the government use are very, very expensive, but if you use non-expensive commodity servers, your supercomputer becomes a lot cheaper. And if you own your small company with 4 servers to build the big data system, then it's just about $40,000. That's a lot cheaper than owning supercomputers. So anyhow, Google, after Google made that system, like a Google File System and MapReduce, they published the papers around 2004 to show up themselves how they collect and process those large-scale data sets. So, motivated by that papers by Google, the Apache open source community, especially the one of the Apache committers named Doug Cutting. He was involved in many projects such as Apache Lucene, that is for search engine, and also Apache Nutshit, that is for website search engine. Were interested in Google's idea, so he started Apache Hadoop project, and he is actually working at at the moment Doug Cutting was at Yahoo, and now he is at Cloudera as a chief architect. Okay, and this is a photo of Doug Cutting like 2 years ago at New York Strata Hadoop World Conference. So at this moment, I just want to define big data. Big data, I mean, the name itself sounds like that is a large-scale data set, but actually, big data is inexpensive framework that can store a large-scale data set, and also can process it quicker in parallel approach. Okay? So big data is actually platform, and mostly most popular big data platform is actually Hadoop, and it is non-expensive supercomputer because it is parallel computers, and also it is not expensive, so you can own your own supercomputer these days. I mean Hadoop cluster, mostly using probably 4 servers. If you are big companies such as Yahoo, Facebook, and like Google, then you may own 15,000 servers as a single Hadoop cluster. So, okay, before I move this slide, again, so Hadoop is composed of 2 cores. One is for storing data, and another one is for processing data. So it is composed of actually HDFS, Hadoop Distributed File System, and also MapReduce. Okay. I think I could show you some here. So anyhow, so once you have a Hadoop cluster that is composed of many, like several servers, you could actually process data, but the Hadoop has been in the world for like 10 years already, and then the many companies who adopted the Hadoop cluster actually started building their own solution. For example, actually those solutions are called the ecosystem, because most companies, they donate their solutions to Hadoop community, so any user can use it and adopt it free. So for example, for data analysis, there's a Hive that is donated by Facebook, also Pig that is donated by Yahoo, and also there's Impala test, like BigSQL, Big Shit that you have seen in the class. Also for data streaming, that is to collect real-time data and to analyze it and store it. That is actually Storm from Kafka. And also to exchange the data with the traditional relational database, there is a Scoop. And also for in-memory processing, there is a Spark that is actually has been replacing MapReduce. So those are all Hadoop. I mean, there are more Hadoop ecosystem, but those are kind of a popular Hadoop ecosystem that people are using. So once you have a Hadoop cluster, you can install this Hadoop ecosystem for your own business applications. For Hive and Pig, those are kind of popular and easy approach to use a Hadoop cluster. As I said, that is built by Facebook and Yahoo. And also the Hadoop, like HDFS, Hadoop Distributed File System is actually a file system, but if you use Hive and Pig, you could regard your Hadoop file system as a data warehouse. And you can use it like a similar to relational database. Okay, and the basic idea of Hive and Pig are, if you use MapReduce, you have to write a Java code to build the map and reduce functions. So it is really hard to build the data-related application. So the Facebook and Yahoo started building new system that is much easier and much faster to write a code. So once you write a Hive or Pig code, you could simply, those Hive and Pig code can be simply converted to MapReduce jobs once you submitted it, and then run your code on Hadoop cluster without any problem. So, for example, if you want to join data from multiple data source using Java to build the MapReduce code, it may take 7 days or 10 days. But if you use Hive QL, query language, then it takes like 5 minutes to join multiple data sources. Okay? So Hive, Pig, like a BigSQL is the same thing. BigSQL in IBM, those are very, very useful tool, useful ecosystem that can analyze your data much quickly and run on the Hadoop cluster. But definitely MapReduce jobs, that is actually batch processing. Batch processing, as you know, you need to collect the data and then you have to process it later. Okay? So it's not, also MapReduce job, even though it is very small job, you have to, it takes time to run it in the beginning. Maybe it takes like 30 seconds to 1 minute to start it. So it's non-interactive jobs. So to avoid it, to beat it, to make interactive the SQL, actually there is a BigSQL or Cloudera Impala that runs on MPP, the massively parallel processing. That is the traditional parallel processing approach. But if you run SQL using Impala or BigSQL, you can get the result in 2 to 3 seconds. That is like almost real time. And the good thing of Hive is same as BigSQL. It is based on SQL syntax. So anyone who knows traditional database can easily move to Hive to run the code in parallel on top of a Hadoop cluster. Also, Pig Latin, same. It uses a very simple script language. So even though you are not good at coding, you can easily learn how to write a script language. But again, BigSQL and Hive QL are much easier because it uses SQL syntax. And this is kind of a logical diagram of how the Hadoop cluster could be built. It's kind of similar. Your Bluemix has a similar logical diagram. Only exception is the storage, object storage are located at different locations. But in here, there are like 9 servers. On the top, there are 1 server that is for monitoring the servers. Okay, so there are total 10 servers, and each 3 servers, they are kind of racked, and so there are 3 racks that has switches. There are 3 switches that they communicate each other, and each server has the HDFS and the MapReduce job. So in this example, there are 9 servers. This is kind of a small company who own a Hadoop cluster with 9 servers. And if you are much small, the center or the company, then you could start with 3 or 4 servers to build the Hadoop cluster. But if you don't want to maintain your own servers, you can use IBM Bluemix or the Amazon AWS or the Microsoft Azure, the cloud computing services. because you don't need to maintain your servers. Now let's move on Spark cores. So as I said, the MapReduce has been replaced by the Spark because normally you have to write a Java code for MapReduce, and it's not easy. Also, MapReduce has a limitation because it is batch processing. It's not interactive. Also, when map generate a intermediate data, they should be stored into disk, and then reducer need to read the intermediate data from the disk. That actually has a performance issue, especially for machine learning, because in machine learning there are like tens or hundreds of loops. So if you read or write data from or to disk, it's not going to work. I mean, you cannot get high performance. But fortunately, the UC Berkeley AMPLab actually, they were actually famous for parallel and distributed computing, and they initiated the Spark project. That is actually in-memory storage for intermediate data. So simply, any data doesn't need to be stored into disk, but it is stored in memory. So it improves your performance like 10 or 100 times faster. Also, the good thing is Spark can be integrated with the Hadoop cluster, especially for HDFS. Remember HDFS, the Hadoop Distributed File System, is actually to store a massive data set. And then for processing this data, you could just use Spark instead of MapReduce. So in Hadoop, again, Hadoop is composed of HDFS and MapReduce, but MapReduce is replaced by Spark. And also, the Spark can connect to HBase. There is NoSQL DB running on Hadoop cluster, also Hive. And also, it has many data types that can the Spark can adopt many data types, file types such as sequence file, Parquet, or the ORC. They are very popular in Hadoop world. And also, it can easily integrate with cloud computing such as IBM Bluemix that use object storage instead of HDFS. Also, Microsoft Azure that also use object storage, and Amazon AWS they use S3. Okay, so Spark can be easily integrated with those cloud computing, especially their storage. Okay. Again, since we are using IBM Bluemix, so you get familiar with the object storage to store data and file. But for Hadoop, the file system should be HDFS. But cloud computing service, they have their own file system, such as object storage or Microsoft Azure object storage or Amazon S3. Those are their own file system to store a massive data set. Also, the Spark is good in complex multi-stage applications. Simply, it is good for loop, such as iterative graph algorithms and machine learning. Also, the Spark SQL is relatively faster than Hive. So you can say it has interactive query. And Spark Core is composed of the APIs such as Spark SQL that has data frame. Also, you can use SQL syntax here in Spark SQL. Also, for real-time streaming data, there is a Spark Streaming API. Also, for machine learning, there is a machine learning library. And also for graph algorithm, you could use GraphX API. And if you're good at R, you could use Spark R. And those API are based on the Spark core, such as RDD and transformation and actions that I'm going to explain in other slides. But anyhow, the point is, in your assignment, you will see how Spark SQL and how machine learning library works. And again, those are replacing the MapReduce, so you don't need to waste your time to work on MapReduce coding. Also, Spark has been popular these days. So, like, I went to Spark Summit like a few weeks ago in San Jose. I mean, in San Francisco. The participants were like about 2,500, even though Spark was kind of new. So many people at the industry are interested in Spark a lot, and they use it actually. And Spark has 8 drivers and workers. Simply drivers are our client with a Spark context. So when you take a look at the code that I gave you, you will see Spark context in the beginning. Spark context is allowed to create RDD, the resilient distributed data set. Also, you could use Jupyter, IPython notebook for interactive coding. And also, there is a Zeppelin that is similar to Jupyter, but that has much, that is more flexible. And IBM is adopting Zeppelin, but I don't think it's there yet officially. But IBM tried to adopt Zeppelin as well. But it is almost same as Jupyter as a developer. Also, there are workers. That is actually Spark Executor that runs on mostly cluster node. But for development, you can run it in local thread as well. I mean, if you have a laptop or a single computer, desktop computer, you can just run the Spark as a single the server. So logically, if you have a Spark code that belongs to Spark client, and then if you submit that code, that will the scheduler will generate a logical diagram, and assign those jobs into actually Spark workers. And Spark workers is composed of the task thread and block manager. Task thread is to make your job to run on this server, and block manager is actually to manage the file system. And so if you take a look at the picture again carefully, the cluster manager is actually mostly Yarn. And also, if you don't use Hadoop, it could be the Mesos. So the cluster, I mean, to manage your Hadoop cluster, the Yarn has been used. But if you don't use a Hadoop cluster, if you just run your own Spark cluster, then Mesos could be used as well, because originally Spark Workers cluster manager was Mesos, but Hadoop has been too popular, so Spark is actually integrated into Hadoop cluster with so it is controlled by Yarn these days. So anyhow, if you take a look at Spark driver or client, you have only single server, but Spark workers, you will see there are multiple servers, because Spark workers are the place to run your Spark job. And also, the data is in Spark workers, so you don't need to waste your time to read the data to run Spark task. And also, Spark driver is to monitor Spark workers to see if there is any server that goes down. Also, to assign the Spark code to the task to the server in Spark workers. And also, Spark workers can also communicate with the HBase or object storage over IBM, Bluemix, or Amazon S3, etc. And now let me move to the concept of the RDD. RDD is the resilient distributed data set that are distributed collection of objects. And you can cache it in memory to speed up. And RDD could be data streaming RDD or data schema RDD for SQL or pair RDD for key value. And RDD is immutable. It means that if you try to modify the data of RDD, you should actually create another RDD. Okay? So new data generated from current RDD should be stored into another RDD. Also, there's a lineage that shows the history of the object. It means that there's kind of like a family tree. So there is a parent RDD that generate child RDD, and child RDD also could generate grandchildren RDD, and those are all connected. So if you lose data of grandchildren RDD, then you can regenerate from child RDD because there's the history, family tree history to go up to the parent RDD or grandparent RDD. Yeah. So you, even though you lose data, you can automatically and efficiently recompute it from that lineage history. For RDD, there are two most important operations. One is the transformation, another one is the action. Transformation is to define new RDD from the current, such as map, filter, and join, that you could see in the assignment code. And the most important concept of transformation is actually lazy computation. It means that if you take a look at the code, transformation function is just to define new RDD, but the data is actually computed yet. So as a human being, you can tell, oh, this RDD generates that RDD, and that RDD generates another RDD, but the computer itself doesn't compute the data yet, unless action is called. So there is an actions operation that is actually to trigger computation, and also it returns values such as count function, collect, take, save. Those are action functions that trigger the computation. So unless it is called, the transformation never compute any data. Okay, so that is actually a lazy computation, and that is the most important concept that you have to remember. And to write a code in Spark, there are three popular languages. The first one is Scala, and Python, and Java. Scala is functional programming language, and functional programming language is popular for parallel programming because the parameter is function, so there is no way to generate the side effect. Okay, or we could say there are no state. So since there are no state, so I mean, in parallel computing, you have like several nodes that run together. If one server generates a state, other nodes should know it, but it may cause some problems. So that's why functional programming is good for the parallel programming, but it takes 30 minutes or 1 hour to explain it. So I'm gonna just type here, but simply there's no side effect using functional programming. So that's why Scala has been popular for Spark. Also Python, you can write a code in Python as a kind of a functional programming language. And also Python is a legacy and traditional language that has many libraries that you can use. For example, for visualization, Python supports many good the API. but Scala is pretty new programming language, so it doesn't have a good visualization API. Okay? And Java is good, but Java is object-oriented language, and to write a code, Spark code in Java is still kind of complicated. So people normally use Scala or Python. So at this moment, it's like 50% to 50% to use either Scala or Python in industry. Now let me move to a brief introduction of a Spark API. Spark SQL, that is to turn on RDD into a relation that use SQL and data frame. So once you know SQL syntax, you can easily adopt Spark SQL. I mean, you can write a code in Spark easily. Also, Spark streaming, that is streaming data to collect the data in real time and also to analyze it in real time. And machine learning library that provide many good machine learning algorithms such as sparse vector support, decision tree, linear logistic regression, PCA, etc. And your example 4.2, like assignment 4.2, use how to use a logistic regression to see how it works for checking, I mean, to predict the air conditioner system. Now let me move on Bluemix Cloud Computing. Spark run on many cloud computing, such as, for example, Databricks. Databricks is built by the UC Berkeley AMPLab, I mean the staff of UC Berkeley AMPLab, and it has been popular. And they always generate latest Spark library. And Databricks provide a community cloud service that runs on actually Amazon AWS, and it is free, so you can sign up Databricks community cloud computing service to write your own Spark code. And also Amazon AWS support Spark, so there is a way to run and write a Spark code. Similarly, Microsoft Azure and IBM Bluemix also strongly support Spark. So as some of you already have done, you can easily write a Spark code and run it. And also IBM was a little behind it before when Hadoop came out, but because Spark came out, they can easily, I mean, it is much easier to catch up with Amazon or Microsoft Cloud Computing. So IBM support Spark. I mean, IBM invests a lot on Spark to compete with Amazon and Microsoft. So IBM Bluemix, as you know, for Hadoop, as a Hadoop cluster, there is a big insight that has Big SQL and Big Sheet, and also it supports Spark, and they invest a lot on Spark again. And also the IBM Bluemix provide many services for computing service. There are Spark, Big Insight, and DashDB, and data analysis that mostly you already get familiar with. And for storage, it adopts object storage, and that mostly in Hadoop, the storage and computing service should reside at the same server. But like in cloud computing, they use object or block storage that are separated with the computing service. But data and computing service are connected through really high-speed network to overcome the latency between, I mean the delay between the computing service and storage service. So I mean, because there is a concept of process-intensive computing that is for traditional supercomputer. Because traditional supercomputer separate the computing service and data storage. So for big data, there is a latency between the data and the computing service. So the supercomputer is not good for the big data era. However, the cloud computing service actually get over that issue with the high-speed network. So when computing service read or write data at data storage service, there is no latency that much. Okay? So like a computing service and data service are running like a same node, same computer. So now let's move on the assignment. Assignment 4.1, especially 4.1a, is actually to create, to know how to create Apache Spark service at Bluemix. Also, you should know how to create an object storage to upload your data to Bluemix's object storage. Or if you have already data in object storage, you can just use it as a folder. But again, object storage, that is the concept of write once. So once you have an object, once you have a data in object storage, you cannot change it. So you have to delete or you need to recreate another object. So in 4.2, you will generate a Parquet file. But once you generate it, and if you rerun it, you will see the error message, because the error message will say the object is already there. Okay, so you need to rename the file name. Okay, so this is same for all, like the same for HDFS, object storage, and S3 over Amazon AWS. So it is the concept called the write once. And also you will learn how to use Jupyter. That is actually IPython notebook. So you write a code in Jupyter, but actually you need to import the tutorial that we shared, like a tutorial 1 load data.ipython notebook. And then you need to upload a sample file named 2005-1 to the object storage. So if you follow the assignment tutorial, then it should be easy. It should be very, very easy to upload this file. And in the beginning, there is a simple like a statement to load the file. So for example, sc.txt file. Sc is actually Spark context. That is given by the IBM. So sc.txt file is to read the data. And Swift is the name of the object storage, and depends on your object storage name. That could be capital notebook or lowercase notebook, but it is case sensitive, so you have to be very careful. And then under there, if you have a file named 2015-1.csv, this statement is actually to read the data from this object storage. And then for each cell of the code, you can run it. And also you need to take a look at what that statement actually means. Is it like a transformation function or action function? So anyhow, if you follow the tutorial, assignment tutorial, then you can easily see the result. For 4.1b, we will use actually tutorial 2 Python data analysis IPy notebook code. Here we are going to use 2015.csv file, but before you use it, you actually need to test this code with the sample file that we have used in 4.1a. And initially, actually, we want you to download the real 2015 weather data from the weather website, but we realized that that is about that is a gigabyte file, and there is no way to keep that big file in our local system. So we decided to use only the 159 megabytes of 2005.csv file. So you can download it from the course website and then upload it to object storage as you did in 4.1a, and run it with the tutorial 2. Then you can just answer the questions that is shown in the rubric. Then you will get the full credit. For 4.4, this is how to use Spark machine learning library with the logistic regression function. That is actually to check, to predict how the air conditioner works. So if you take a look at the input data file, hvac.csv, there is like a system name, system age, and building ID, and also there's a target temperature and actual temperature. So it means that as a human being, you can actually control the air conditioner to set its target temperature, but for some reason, maybe the system is too old, so actual temperature is much less or much higher. So we collect, actually we assume that we collect this data from many buildings that has an air conditioner. Then we can tell, if we train the model using logistic regression, then the model can predict if when we see new air conditioner system, depends on system information, we can predict that if this system works well or not. That is the point of this assignment. So simply, again, using the existing data, we train the model, and then we select some test data to check if this model works well or not. And then the model that we built, we trained it should tell if this system's actual temperature becomes much colder or hotter than our target temperature. Okay? So if actual actual temperature is much hotter than target temperature, it is represented as 1.0, or if the actual temperature is much cooler than your target temperature, it becomes, you will see 0.0. Okay? So this example should be very interesting for you, and also very simple. So you could adopt this assignment for your real life data science. Actually, this is data science related to the assignment, and also the data scientist, like a data science. The Harvard Business Review said data science is the most sexist job in the 21st century. Okay? So I hope the assignment 4.2 give you some kind of idea how the data scientists build the system to predict the future. Okay, so basically that is all for me to present today. Do you have any question? By the way, the
I have-
CDH, there is a question from Chris. CDH is Cloudera Hadoop distribution, like a Cloudera distributed Hadoop version. It means that, like a Linux is open source, but there are companies such as Red Hat or Ubuntu who add more functions to original Linux to make people easily use, right? Similarly, you can download the Hadoop at Apache Hadoop website, but it's not easy to use. But there are companies such as Cloudera or Hortonworks who have their own Hadoop distribution, and they are free. And if you download it, you can easily install Hadoop into your servers. Yeah? So I strongly recommend you to use Cloudera Hadoop distribution or Hortonworks Hadoop distribution instead of using vanilla Hadoop from Apache Hadoop website. You could use any question using chatting or using your voice.
Hello. Can you hear me?
Yes.
Hi, how are you? It's Chris.
Good. Hi, Chris.
Thank you, first of all. This is helpful. One question I have about, I think you've shown a light on one thing that I think was not entirely clear to me before, but I think if I understand correctly, kind of the difference between MapReduce and Spark is not so much about where the data is stored, but how it's being processed when we're querying it. So, for instance, when we are querying it, so like MapReduce would store intermediate data, and I think this is what you said, like on an actual disk that spins round and round, versus Spark, which would store that intermediate data on RAM. Am I understanding that correctly?
Yeah, that is absolutely correct.
Okay. And then related to that, you had said something about how if you're running Spark, you can run it on a Hadoop cluster, but you might also run it not on a Hadoop cluster. That would be something like, I think I saw a video, is it MapR or something, where, and again, correct me if I'm wrong here, but if I understood it, so Hadoop clusters all have to be this, you have to configure whatever size it's going to be, and then they all have to be the same size, whereas other types of clusters, you can choose your size? That's where I think I'm a little unclear.
Sure.
Does that make sense?
Yeah. You know, when Spark first implemented by the UC Berkeley, they had their own file system called Tachyon. But Hadoop has been already popular in the market for like 7 years or 8 years when Spark came out. So Spark needs to be integrated into Hadoop cluster. So only thing that Spark can kick out is MapReduce. So Spark, when it is integrated into Hadoop cluster, Spark itself just give up the methods, resource manager, and Tachyon, the file system. So that's what happened. So simply, Spark is integrated into Hadoop cluster, but it uses Hadoop distributed file system instead of using its own file system called the Tachyon.
Oh, right. Okay. I think that helps. Thank you.
Oh, thanks.
I have a few more, but I don't want to take the floor from other people.
If there is no question, you could ask me.
Okay. So you mentioned about, I think I understood about where you're talking about transformations and actions, and how you can't, like a transformation such as filtering, whatever, doesn't happen until an actual action is called, like counting or something like that. If there were a situation where you wanted to force a transformation, I can't think of a specific reason why, but is that something that you can do or would do in certain circumstances?
I'm not sure if I get your question clearly, but Transformation is just to transform data to another format or another form. So like a filtering data or transform data to another form. But if you don't call action, that is just to trying to create new data, new RDD, but it actually doesn't run yet. You have to call action to make it work.
Right. Okay. Okay. Yeah. I mean, I could, like I said, I couldn't think of a particular example, but it crossed my mind. I didn't know if that's so. Okay. And then another one. I'm trying to decide which one to pick next. The Jupyter file that we're running for our tutorials, that reminds me a little bit of what I had seen a colleague of mine at work create. Like it was a markdown file in R. Are those kind of the same thing or similar?
Yeah, it's the same concept. Like a Jupyter, Python notebook. That is to allow the developer interactively write a code and run it to see the result immediately.
Okay. So I'm going to ask another question. This is maybe something that maybe I've not fully understood about the whole big data, unstructured data, how we're storing data, and I hesitate to ask it because I think I'm going to feel dumb, but I'm going to ask it anyway.
No, it's okay.
But when I hear, so my background is actually fairly simple. Like I started with databases 20 years ago using Microsoft Access 2.0, so I'm very familiar with the relational database model from that perspective, and, that was the bulk of my experience before this class. I mean, I've had some exposure to, like, working with business objects, SAP business objects to query our data warehouse at work. But so I'm just like, my brain is still stuck in that, rows and columns and needing to have, and I understand now we're talking about, all this other data that's being gathered that's unstructured and not in format, and the organized parts of me just want, like, it feels like hoarding, we're just putting anything and everything wherever we want, and, not putting stuff away where it belongs. And so when I think of it, like, where my brain just, I think, isn't entirely wrapping around this, what I hear when I hear things like, you can just grab the data and we'll deal with it later, I feel like, and maybe this is what's happening or maybe it's not, but so, like, for instance, I have, 7 Excel documents and 3 Word files and 2 PDFs at work, for instance. Is it saying that, like, is that what we're talking about when we're saying we just grab data of various kinds? Like, I struggle to figure out, like, how in the world would any type of code know how to read my Excel file, for instance, that might have 4 worksheets in it, and or is it really that unstructured, or am I just not really understanding what we're talking about when we say that? Because in my mind, you still need to have, like, how does it know? How do we know that I'm reading, I can't even think of a good example, like comma delimited. I'm sorry, I'm sort of trailing on here. Do you understand what my question is?
I understand it. Chris, actually, what you are asking is many people are asking. But think about this. We have a file system, right?
Yeah.
We have a file in our computer, and we have a file system.
Yeah.
The database came up because we want to organize data in structured format. Right. We have a table. We have a student table that has student ID column, name column, phone number column, and we add the data into there, right? Mm-hmm. So we started with a file system. Now we have a database with a number of tables. Now the big data came out, Hadoop came out, and it started with the Hadoop file system. It means that the Hadoop file system can store any kinds of files because it is simply file system. So like we did with Java or C++, we can write a code that can read any file in the file system, and we can analyze it. That's what we are doing. That's what Spark and MapReduce are doing.
So it's going and
the only difference
makes my brain hurt. Yeah. Sorry.
Only difference is it is like a massive data set. It is not small data set. It is like 1 terabyte data set. But that is simply just file, like a regular file, like any CSV file, any text file, or any compressed file.
But it's still rows and columns. It's like when I think of, here's the thing, like so at my office, for instance, we have different programs, and you know those. When I say programs, I mean like not computer programs, but like it could be a grant program, or it could be a that kind of thing, or a education program. That's what I mean by the term program in this context. But so like program A might store data in one system, and program B might use another system. Like you've got to be able to get those all to talk, which means you need to have like. I'm sorry, I'm trying to figure out how to. I'm not sure I'm able to phrase exactly what I'm saying, but I think I'm still struggling with.
No, it's like this. I mean, it is exactly the same as what we did before. Only difference is now we use more servers than this cluster, and the data itself is not stored as a structured data set. So, for example, again, you have a file, like 1 terabyte file.
Yeah.
And using Spark or MapReduce, you can analyze it as a text processing, right? That's what we did in the beginning.
Oh.
When the computer first came out, there was no database. Yeah. So using Digi or Fortran, you need to read the file and you need to analyze it, right? Similarly, the MapReduce and Spark, it read the file and analyze it using a text processing approach. However, same as like a database, database came out and it organized data in structured format using table, right?
Right.
So in Hadoop world, people think about it and they try to make data as a kind of a semi-structured data set. For example, like a CSV file. Yeah. CSV file, it is text file. However, there is a comma that separates each value, right?
Yep.
So if you have a CSV file and if you read it using BigSQL or Hive, you can pretend. You can use query to easily analyze that file. So there is no database in Hadoop, but you can pretend. The file is like structured data, so we can use SQL, such as BigSQL or Hive.
I see.
That is what's happening. Also, there are other industries who build NoSQL DB, such as HBase or MongoDB or whatever. That is a little bit different approach. They don't use Hadoop file system. They initially use a structured data set.
Right. But like, yeah, okay. So then in that example, for instance, my Excel file with, headings in 4 different places on one page and, actual rows and columns in another, like, it's not, I would still have to be able to read it, to be able to analyze it, like I would have to be able to tell whatever. I mean, I'm using Excel as a bad example, and just because it's what's, like, how do I say this?
So simply like this.
Like if it's not rows and columns in the spreadsheet, it's that I'm not going to be able to analyze it just because it's data, right? I mean,
as a human being, if you can tell if that CSV file or Excel file has a hidden column, then you can upload it and build the Hive table, for example, to use HiveQL to use SQL actually to analyze it.
Right.
But if you don't have any like a hidden column, if that is pure text, then you need to use text processing.
Yeah. I guess what I'm saying is, like, if I had and this is again a very simplified example, but if I had a spreadsheet with, something in row C14 and something else in D27 and something in, H45, but nothing else, like there's no key there's no nothing to tell me what those mean. That like that I don't think I could analyze in any organized fashion.
But if there is a hidden structure, then
I guess
you work as a data engineer to transform that CSV or Excel file to structure the data.
Okay. I think I see what you're saying.
Yeah, that is the role of a data engineer.
Right. So somebody has to kind of step in and just like because I think the way I was hearing it was like, oh, I have this random file, I'll just stick it in Hadoop, and then magically it'll kick out.
No, there's no
you can't do that. I was
no,
like,
you can't.
I don't think it works that way, but that's the way it kept coming across in conversations when I was.
Exactly.
Okay.
Well, normally data engineer use Spark or MapReduce to transform that data to structured data, because that is assuming that is a large scale data set.
And so that's where data engineers are also, I think, maybe the ones who are, like, to me, a big issue in any organization is going to be data governance, where, if we're talking about people in Department A and people in Department B, you need to be able, or that's a bad example because they probably wouldn't be in both departments, but, you want to have a common way to, well, maybe that's a simple, if you're going to identify people by an employee ID number, then you want to do that across the organization and not have it be, their social security number in one place and their phone number in another place to identify people, right? Not that phone number would be a good way to identify people, but you get my idea. You still have to have those kinds of procedural structures in place that allow you to analyze data across organizations, across departments, across, like that doesn't go away, obviously, and that sounds like that's where an engineer and or others, maybe data scientists, architects, maybe not architects, but are going to need to put those governance structures in. I think that was in one of the other videos we watched earlier. Because to me that's huge. Like, if a lot of the problems that we seem to run into, and that I've seen so far, are just, we can't just get this system to talk to that system because we have, 120 different ways of referring to the same thing, because, and that isn't cured by Hadoop or big data or anything like that. If I understand right.
Yeah.
Okay. Sorry, I've taken way over time here, but I appreciate the clarification.
Sure. Any other question from any other people?
Hello, I was going to ask about tools like visualizations. Sorry, Femi Gundemu. I want to ask about the normal. If you're working in like the example we saw in the exercise, you are working within a notebook, and you're using Python to interact with Spark. My question is, if I want to use other Python tools, like maybe visualization, I want to call them Matplotlib library in Python, would I be able to do that from that PySpark environment, or do I need to like save the data to disk first and then run my visualizations on it?
Yes, the simple answer is yes, you can do that. And our assignment has that example already.
Okay.
You will see Matplotlib library.
Okay. So, sorry, just for confirmation, that means that the whole Python library is also open to me. I can call Python functions on my RDD as I'm processing it in with Spark. And
okay. But you need to parallelize it. You need to use some transformation or action functions.
Yeah, to kind of reduce the data set a little bit before I now process. Right.
Actually, to parallelize it.
Or to parallelize it.
Yeah.
Okay. So let's say I parallelize it, and my data, my RDD gets distributed across many systems. If I call a Python function, a very simple Python function on it, how does that work out? Does it parallelize Python as well?
Yeah, exactly. So once you have data,
yeah,
if you parallelize it, it becomes like parallel RDD.
Yeah.
And it is automatically distributed to a number of server.
Okay.
By the Yarn.
Okay.
So once you write it, the system Hadoop cluster automatically do it.
Okay.
That's why it is very, very convenient.
Wow. And it keeps all the complexity of that away from me. I just call my function and it gets it done.
Exactly. So the traditional supercomputer is really hard to write a parallel computing code, but here in MapReduce and Spark, it becomes very, very easy.
Okay. Thank you.
Sure. Any other question?
This is Chris. Can I ask one more?
Sure.
try to keep it shorter. One of the slides mentioned something about graphs. I think it was your Spark cores slide.
Mm-hmm. Mm-hmm.
Like, my first instinct when I hear graphs is to think of, X and Y axis on an Excel spreadsheet or, something like that. But I think that's more talking about a mathematical approach. Is that correct? Am I hearing graph correctly when you talk about it?
Graph here is like a tree structure, like a social graph.
Oh,
so,
okay.
So once you have once you have a vertex and the edge information, then using GraphX, you can easily compute the graph data.
Okay, I think I read a little bit about it's almost like you have like social networks, for instance, on Facebook, or transit networks in aviation, or Amtrak, for instance. Is that is that kind of what we're talking about?
Yeah. So if you have data, the file that has that vertex and edge information, and using Spark, you can easily process or analyze it.
Okay. Yeah, that's just something I'm not really going to explain to you now. So, okay, thank you.
Sure. Any other question? Any question?
Can we have another week on our assignment?
Sure.
No, I ran into some snags yesterday, but I think we're past them. So. Mine required me to have two notebooks, a small capital or a capital N and a small n, and I'm not quite sure why, but I don't know if that's true of everybody or just me.
The depends on how you create your notebook.
Yeah, it's not, that's something I can worry about.
Yeah. So again, it is case sensitive. So once you create your object storage with a capital N, your code should refer to capital N notebook. So the Spark code is case sensitive.
Right. Yeah, I did see that, and I thought I had the right. I thought it was non-capitalized. Whatever. That's the stuff that needs to be talked about here. I'm just curious if that was typical or not.
Any other question? No question? This is a good chance for you to ask any question.
Hello, this is Solomon.
Yes.
Just a question on the object storage.
Mm-hmm.
The Bluemix assignment we're doing. Can you erase or delete a file from the storage, from the object storage? I find it difficult to do that. Even though there's a facility for doing that in provided, but you click on it and it doesn't, the file doesn't move away. Is it?
Yeah. You can delete it anytime. So maybe
it's an auction drop down, and the drop down that's called auctions.
Yeah.
You pick add to add, and then there is also an option to delete.
Yeah, we do that, and
it's in a drop down. If you open up the object storage where you see the files, there is a drop down called auction, and you can pick if you want to add or delete. It's in there.
Yes, and I see that, and even for creating containers and so on, isn't there?
No, it's inside the folder. It's inside the container.
Okay. I find it difficult to erase any file created, and so you have to give several file names, and the container becomes cluttered. There's a lot of files in there which is not used. Okay, thank you.
Yeah. You keep trying. Then it is very, very easy to delete it.
Okay.
Any other question? Elena, it seems there is no more question. Maybe Elena is not here yet, or somewhere.
Oh, I was talking in mute, sorry.
Oh, sorry.
I was talking in mute. Yeah. Well, I was distracted by some noises anyway. No, if there are not more questions, I just want to remind you that if the presentation for the last Spark Summit are free, and I posted the link in the class announcement, so if you get chance, you can see the last thing which the Spark community is sharing. That was, I think, the second or the third summit on Spark, because this is relatively new, let's say, new tool and new community going around, but it's picking up with very fast. So I suggest you review whatever you can. Very valuable presentation there. And I don't have more. If there are no questions, we just ending this meeting and keep asking questions and reviewing, because we just have 3 more weeks. And still group projects, I see people still are not working, but it has to go in parallel with everything. So find out the time to get together and to work on that also.
Dr. Gorcheva, you mentioned that which presentation were you talking about again? Was
the group presentation?
No, before that. Yeah,
oh,
no, you had,
okay. Let me share what I'm talking about. Okay. I know there is too much, and not everyone. Let me share. I will share what I'm talking about.
Okay, thank you. Because there was something that was like an all-day thing. Was that tomorrow?
Okay. Sure. Application. Here it is. Here is our class. What I'm saying that the Spark Summit, all the presentations are here, and you can watch them.
That one.
Let me open, and you will find a treasure here. Just time. Okay, the training, 3-hour video. You can watch it. First part, second part. You can watch. Everything is free. Everything. So all this open community, I want that you evaluate which tool we are talking about in this class. This is the top, the high, the hot, whatever adjective you want to put right now, Spark. If you prepare your resume tomorrow to get a job, and you can put some experience on Spark, right now, this is around $1,800 more. Okay? So that's why I suggest not just to concentrate to doing well in the class, which I admire, and I'm very happy how everyone is trying to do his best in the class in order to get the best grade, but also evaluate that this is the open source tool now, and there is huge community sharing and working on this. Even an event like this, the resources are free. It was just a month ago in June, and you can see everything here. That was the thing I was talking about. Any other questions? Yes.
Thank you.
And also, what else I was sharing? Tomorrow is very interesting other stuff. If you find is the smart data, this is totally online event. And you know, we started with big data today, after 10 years having Hadoop, storing this data, like the professor Wu pointed to 2 directions, storing the big data and processing the big data. Storing the big data is not issue anymore. No one cares about this. The issue is processing data, and the issue is getting something valuable for this data. So now, more important is the tendency of the transition of big data to smart data, because you understand the hype about big data is not anymore a hype. Why? Because the expectations are fearful. So there is no more hype about big data. The new start is smart data, because it's really what you valuable find of this data. So the processing is the important part. And this event tomorrow, which is here, you can sign up. It's totally free. It's Pacific time, 11 Eastern, 8 Pacific to 3 or something like this. I have in my calendar, let's see how many presentations I can see tomorrow. but it's very interesting, and this is actually the part of the course we started when we start talking about unstructured data and talking about where the big value is of unstructured data. So in Hadoop file system, you don't have a problem to store any data, structured, unstructured. This is just flat file divided in chunk of 64 megabytes and spread all over the commodity server. So storing is not a problem. The problem is the insight for the data. That's why we are moving for the term big data. You will start listening less about big data because there is not too much already there. Unless we are talking about a slide I want to remind. Let me see if I can share something else so we can make this point. And the worst thing is I have to stop a share again. The other application, PowerPoint. I just was listening. So here is the thing. It doesn't matter what you are going to store in Hadoop. Either structured data, which is in table, or totally unstructured data which describe the same stuff. What you are going to store in Hadoop is a flat file system. The issue is how you are going to extract this data, what you were talking about the data engineer with the different tool. One useful tool to extract structured data would be the BigSQL, but for the unstructured data, here you understand that we have to apply techniques of natural language processing, and we are talking about, when we talk about smart data, we are going to this direction where we don't have any structure, but we still can find the answer from this unstructured data. So I just try to summarize. I don't want to put this more difficult, so if you have any follow-up. These were the two events I wanted to share, and they are in the class announcement. The links are there. Okay? Any other question? No more question? So, I think this was a productive session. And I hope you will try now at the end of the course, you get more clarity about all this ocean of different, let's say, different terms we are talking about in the term of big data analytics. So you can kind of start structuring the knowledge in this class. That is the hope in the last quarter of the course.
Thank you, very helpful.
Okay, guys, if no more questions, good night for today. Well, good evening, and have a productive evening. I know most of you are going to work now on whatever duty you have. Bye.
Bye, everyone.
Bye, thank you.